good access roads resulted in the unique method of erecting the steel members with a cableway. The method had been used before, but never on such a giant structure. The cableway was actually a bridge that would build a bridge. After 4 330-foot towers were completed, 2 on each side of the gorge, a helicopter carried a 1/2-inch cable, 5,000 feet long, and weighted against sway across the wide gorge, where it was secured to a 1-inch cable connected to a hoisting engine. The hoist then pulled progressively heavier cables back and forth across the gorge until rugged 3-inch cables with tremendous lifting capacity were solidly secured to huge, deeply embedded anchors. Building so long a bridge in so short a time demanded good strategy and scheduling. American Bridge, with total construction responsibility, programmed many of the myriad of tasks simultaneously to keep on schedule. Thus, while abandoned mine shafts were being sealed and the hillsides stripped of vegetation, concrete forms were being built and filled by the Foster Creighton Company. At the same time, fabricating plants at Ambridge, Pennsylvania and Gary, Indiana, were busy preparing the thousands of steel members which were to convert mathematics to reality. There is no such thing as a little mistake on a big bridge. If every piece didn't fit precisely during erection, the entire project could be delayed. So most of the great bridge was actually assembled twice, once in the shop and later at the site. Imagine the works of Big Ben being made by a watchmaker, and you'll have an idea of the precision with which this bridge was fabricated. Though the main span was 1,700 feet long, all major cord members were milled to a tolerance of 1/100th of an inch. This provided almost 100% bearing between each cord and cut the bolt requirements for all major cords by 50%, a tremendous savings. Delivery of the steel to the bridge site, usually routine, also took some doing. With no convenient railroad siding near the bridge site, American Bridge had to establish a small one at Nayland, West Virginia, 19 miles from the bridge. There, the steel was transferred from freight cars to long trailers, or given its own wheels, and hauled 19 torturous up and down, zigzagging miles to the storage and assembly area on the north side of the gorge. Here, all the steel members were organized to permit the superintendent to demand and get the exact member he wanted, exactly when he wanted it. Because the cableway would permit the hoisting and placing of loads up to 100 tons, individual members were pre-assembled, and portions of the bridge were erected section by section, rather than piece by piece. This not only saved time and money, but also reduced hazards. It is much easier and safer to bolt steel together here than 876 feet in the air. While steel was being readied, work on the concrete footers was nearing completion. Firmly cast into the top of each footer was a sturdy steel grillage from which the steel arch and towers would grow. The first steel was placed in the north approach section. 9 steel bents or towers were required to carry the north and south approaches out to the point from where the great arch would spring. Ranging up to 391 feet in height, they marched up the steel gorge in uniform strides, 127 feet long on the south approach and 144 feet on the north approach. The bridge built to build a bridge was put to work. 2 airborne trolleys, riding mighty cables firmly anchored hundreds of feet back and remotely controlled in tandem by 2 operators who carried out instructions sent electronically by the foreman, were to make thousands of deliveries of steel members and assemblies over the next 2 years. Working alone, each trolley could deliver up to 50 tons. In tandem, the capacity doubled. This was vital because assemblies weighing up to 92 tons had to be handled in the job ahead. Weather permitting, steel placement and connection was scheduled around the calendar. But it was in the worst of weather that the cableway put on its best performance, reaching 876 feet to the valley floor below to hoist up vital members that were too heavy to be delivered by truck over the sharply curving roads. This versatile